we've got a question to prove here. So let's prove that the left hand side is equal to the right hand side. I want to start with the left hand side. So the left hand side is equal to, well, n combination r minus 1. This means n factorial divided by what is on top, n, minus what is down, that will be minus r minus 1. And then we put a factorial there, and then same what is down, r minus 1, put a factorial also. And then plus 2, we have got n factorial divided by n minus r factorial, and then r factorial, and then plus n factorial divided by n minus r plus 1. Then we put a factorial, and then r plus 1, so put a factorial there. So this is the same as n factorial divided by, can distribute a negative to everything there in the denominator. So that is going to give us n minus r plus 1 factorial, and then r minus 1 factorial, and then on top we have got 2n factorial divided by n minus r factorial, and then r factorial, and then we have got n factorial divided by n, distributing the negative to what is inside, negative r, negative 1 factorial, and then r plus 1 factorial. Now our aim is to make sure that the denominator is the same, so we're going to use principle of factorials. When you've been given 8 factorial, this means 8 times 7 factorial. It can also mean 8 times 7 times 6 factorial. So just multiply by the numbers which are below that very number. This is 8. You get it first. Subtract a 1, it will give you 7. Subtract another 1, it will give you 6. And continuing like that up to reaching 1. So if you want to end at a certain number, when you end there, you need to add a factor. So even here, what we have in the denominators, that's what we are going to do. And so this is telling us that when we have been given n minus r plus 1 factorial, this is the same as first we have got n minus r plus 1 itself, and then remove a 1 from here. That will give us n minus r, because this one will also go. If I want to end here, I'll just put a factorial. That means if I've got n minus r factorial, if I multiply it by n minus r plus 1, it will give me n minus r plus 1 factorial. I can as well write this and say this is equal to n minus r plus 1. I reduce it by 1, that will be n minus r. I also reduce it by another 1, that will be n minus r minus 1. I can now add the factorial here. That means if I've got n minus r minus 1 factorial, if I multiply by these two, I'm going to get n minus r plus 1 factorial. That is one thing that we need to know. Okay. And then notice that we have got n minus r here, we've got r here, and then we've got r plus 1. We need to make them the same. Well, the biggest number we have here is r plus 1. R is just 1 unit below r plus 1, and r minus 1 is 2 units below r plus 1. That should mean that if we've got r in this case, r plus 1 factorial, this is the same as getting just r itself plus 1. Remove a 1 from there, you're going to get r. You can put a factorial. So if you've got r factorial, just multiply by r plus 1. Then you are going to get r plus 1 factorial. And then this can also mean you just get first the r plus 1 itself. Remove a 1, that will give you r. From r, remove a 1, that will give you r minus 1. You can add a factorial to this one. So if you've got r minus 1 factorial, if you multiply by r and then r plus 1, you are going to get r plus 1 factorial. So in this case, we're expressing in the same thing. So this one, where there is, so that means we want to express everything in these bases. We should have r plus 1. I mean n minus r plus 1 factorial, and then r plus 1 factorial. So that is what we are going to make sure. Well, this one we've got n factorial and then divided by n minus r plus 1 factorial and then r minus 1 factorial. Now we said if you've got r minus 1 factorial, to take it into this, what do? We are going to multiply by r and then r plus 1 on top and down. So we're going to multiply by r, that is r plus 1 and then r. Even down, r plus 1 and then r. So from here you can notice that we've already converted in this form. And then we're going to go to the second one and then plus 2n factorial. Here we have got first n minus r factorial. We see if we have got n minus r factorial, we want to take it to this base because we can see that's the one which is here. So we can also take this one so that they are going to be the same. So we're going to divide by what? We're going to multiply by n minus r plus 1, this one, for us to convert it to this one. So that is the one we have there. So we're going to multiply on top and down by n minus r plus 1. Even down, n minus r plus 1. Now notice we also had the r factorial here. Oh, sorry, that is in the denominator. R factorial. And we said if you've got r factorial, we also want to make sure that the bases are the same. So this one, we have converted it to r plus 1 factorial. Even this one, when you just have a r factorial, to convert it to r plus 1 factorial, we multiply by r plus 1. So as well multiply by r plus 1. But I'm doing it on top and down so that I don't change the meaning of the equation. R plus 1 on top, even down, r plus 1. So what you do on top, even down, do the same to avoid changing the equation. And then plus, we have got n factorial divided by n minus r minus 1 factorial. Well, if you've got n minus r minus 1 factorial, if you want it to go in this form, you multiply by n minus r plus 1, n minus r. So we're going to do it on top and down. So we're going to multiply on top by n minus r plus 1 and then n minus r. What we do on top, even down, n minus r plus 1 and then n minus r. Now that we have done this, we can simply do the needif one, make sure that they are in the forms that we've said. And so this is equal to n factorial. I can as well multiply r by that will give me r squared, r by this, that will give me just a r. So that will be r squared plus r. And then in the denominator, we said this and this before even those two. Okay, first let's write this one. That is the n minus r plus 1 factorial. And then r plus 1, if you remove a 1, it will give you r. If you remove a 1, it will give you this one. So this is the biggest number amongst these three. So you can as well just say this is r plus 1 and then put a factorial, because we can as well remove a 1 to give us this. Remove a 1, it gives us this one, and then we can put a factorial there. Okay. And then on top, we have got, I can multiply these two with everything inside here. So I'm going to first write n factorial alone. So that means this is going to be 2n, this is going to be negative 2r, and then this will be positive 2. And then each of these I'll be multiplying by r and by 1. So first 2n by r, that is going to be 2nr, and then 2n by 1, that will be 2n. And then we go to negative 2r by r, that will be negative 2r squared. And then by 1, that will be negative 2r. And then we go to 2 by r, that is going to be positive 2r, and then by 1 that will just be a 2. And then in the denominator we are going to have, well, we said if we multiply n minus 1 by n minus r, I mean n minus r by n minus r plus 1, that will just be n minus r plus 1 factorial, because we also have the factorial here. So that will be n minus r plus 1 factorial. If we multiply r factorial by r plus 1, r plus 1 is greater than r factorial. So that will just be r plus 1 with a factorial. And then plus n factorial. Let's distribute this n by that. That is going to be n squared. And then n by negative r, that will be negative nr. Negative r by n, negative nr. And then, okay, first I've done this, by that is n squared. And then this by that, negative nr. And then this by that, also negative nr. And then this by that, that will give me negative r squared. And then we go to 1 by n, that will just be n. And then 1 by negative r, that will be a negative r. And then we're going to divide by, if we get this n minus r plus 1, we remove a 1 to give us n minus r. Remove a 1 to give us n minus r minus 1. So we can just as well just say that is n minus r plus 1, then put a factorial there, and then we also write this one, that is the r plus 1 with a factorial. Alright. Now that the bases are all the same here, what I can do is, we can see that n factorial is common on top on everything. So I'll factorize out that n factorial. I'll put n factorial there. I can put that. In the denominator we are going to have, because n minus r plus 1 is common for everything, and then also r plus 1 factorial is also common. So I've factorized out n factorial, so I'll just remain with r squared plus r. And then even here I'll remain with what is inside there, that is positive 2nr plus 2n minus 2r squared minus 2r plus 2r. Actually these two are going to cancel out, so negative 2r and positive 2r, they are going to cancel out, so I can just leave those out. So this and this will cancel out, so just the positive 2 has remained. And then we go here because we factorize out also, so we're going to have positive n squared negative nr minus nr, that will give us negative 2nr. And then we have got negative r squared, and then a positive n, and then a negative r. Alright, so here we can see r squared can cancel out with the negative r squared, so those two are going to cancel out. This goes with this. And then what else? Okay, actually this negative r I've written here, it was supposed to be a positive r squared. This value here is supposed to be a positive value, not negative. I don't know on my calculation, so let's just see what happened there, because if it is positive, it's not going to work out. Okay, here this was negative r, this was negative r, so it can't give us a negative r squared, so that was supposed to be a positive r. So negative n by n, that will be n squared. Yes, okay, let me just write that again. n by n, that is going to be n squared, as we can see there. And then n by negative r, that will be negative nr, that is true. R by negative n, that will be negative nr, that is also true. And then if we go to negative r but times negative r, that will be positive r squared. And then 1 by n, that will be positive n. 1 by negative r, that will be negative r. So that was supposed to be it. Okay, so this is just the one which is changed, that is a positive. So now let's proceed and reach the stage where we reached. So we are saying, well, the numbers here are a lot, and it's possible that you can, I mean, the letters are a lot, and it's possible that you can write something else. So just got to be very careful when working out. So the denominator, as we've said, is common. So we're just going to write that n minus r plus 1 factorial, and then r plus 1 factorial. So if we write this, that is r squared plus r, and then we go here. Of course, here we already said this and this will cancel out, so just remaining with 2nr plus 2n minus 2r squared, and then a plus 2. And then also there we have got positive n squared, negative nr, that will give us negative 2nr. And then we've got positive r squared, then you've got positive n and negative r. All right, so now this will give us n factorial, and then inside, if we add r squared and this positive r squared, that will give us positive 2r squared, which will cancel out with this negative 2r squared. And then we have got positive r, we have got negative r, which will cancel out. Positive 2nr, negative 2nr will cancel out. Okay, so those are the ones which are going to go. And what are we remaining with? We have got n squared there, and then we have got 2n plus, okay, plus this n, that is going to give us positive 3n. What else? We have got a positive 2 there, plus 2, and then divided by n minus r plus 1 factorial, and then r plus 1 factorial. So this is going to give us n factorial. Now what we have here is a quadratic expression. Well, if we multiply this and the coefficient there, that is going to give us a 2. So the product here is a 2, and then the sum, we just get a number here, that is a 3. So which two numbers can we multiply to give us a 2? If we add them, they give us a 3. Well, that's obviously a 2 and a 1. 2 times 1, that is a 2. 2 plus 1, that is a 3. So we can factorize that was on top as n plus 2, n plus 3, and then divided by n minus r plus 1 factorial, and then r plus 1 factorial. So this will give us, I'm going to start with n plus, and then I'm going to multiply by n factorial on top, because this number is on top. So what we have is n plus 3, that's the one I'll start with, and then n plus 2, and then now the n factorial at the end I'll put, then divided by n minus r plus 1 factorial, r plus 1 factorial also. Now n plus 3, if you remove a 1, you get n plus 2. Okay, and this is not even a plus 2. I don't know what I've written. This is a 1. So we said the product here is a 2 and the sum is a 3. Two numbers to multiply to give us a 2, and if we add them, they give us a 3. So we said it's 2 and a 1. Actually, not a 3 I've written. Pardon me for that. So 2 times 1, that is a 2. 2 times plus 1, that is a 3. So we are saying this is a 1. Okay, that is a 1. So this is 2, and then this is 1. All right, now I can make the statement that I was saying. So n plus 2, if you move 1 unit, like if you remove a 1, that will give you n plus 1. From n plus 1, if you remove a 1, you just get n. So that means what I've written here is as good as just saying n plus 2 and then put a factorial divided by n minus r plus 1 factorial and then r plus 1 factorial. So this is the simplest form I'll reach at on the left hand side. Now let's check the right hand side of this our identity. So this is the left hand side. What are the right hand side? On the right hand side we have got n plus 2. We can put a factorial there and then divided by, we can subtract n plus 2 and then we remove what is the down there, that is r plus 1, and then what we get we put a factorial, and then the something which is down there, r plus 1, we also put a factorial. That is how we work out combinations. So this will give us n plus 2 factorial divided by, we have got n plus 2, this negative distributed, that is going to give negative r and negative 1, and then factorial, and then r plus 1 factorial. So this is equal to n plus 2 factorial divided by n, and then I can first write a negative r there. Now 2 minus 1, that is a 1, so plus 1 factorial and then r plus 1 factorial. So we can see that the right hand side is equal to the left hand side. So hence proven. Well, thank you so much for watching the video. If it was helpful, you do well to subscribe. Have a blessed day.